Let's see some examples on the derivation of the molecular formula of inorganic compounds. Our example starts from question 5. Here, it says, derive the molecular formula of each of the following compounds. First one is silver chloride. There are mostly two sides to a compound. The positive side, the cation, and the negative side, the anion. So here, the positive side is silver. Silver is charged +1. You check your table of charges of cations and anions. Cations are positive ions, such as silver, which is plus. Anions are negative ions, such as chlorine, which is charged -1. Plus is the same thing as +1 or 1 plus. We could write it anyhow. In chemistry, we can write 1 plus, we can write +1, or we can simply write plus. Here too, we can write -1 or 1 minus, or simply write minus. But when it is -2, we must put the 2. When it's also +2 or +3, we must put it, or -3, and so on. But with plus or -1, we can just write plus or write minus. So here I've written down the charge of silver. From this charge, I'll get the valency of silver as 1. Also, here, the valency of the chloride ion is also 1. Its charge is -1, but its valency is 1. Here, the charge of silver is +1. Its valency is what? 1. So what we do next is cross multiply. This will give me Ag1Cl1. So the molecular formula of silver chloride is AgCl. AgCl because in chemistry we don't write our 1. One compounds contain elements that, just appear once. We don't write the 1 beside them. So that's the molecular formula of silver chloride. Let's be faster. B is what? Ammonium triazonitrate 5. Ammonium triazonitrate 5. I'm supposed to write it in a single file, but my screen is a bit short here, so I'll try. But you can write yours in a single file. I can squeeze it if I want to squeeze it. Ammonium trioxonitrate 5 in a single file. No. When the space is no. This is the negative side. This is the positive side here. This is the negative side. So it's a positive side that's always written first. Ammonium ion is NH4 plus. Triazonitrate 5 ion is an anion, NO3 minus. The charge on the ion or radical is -1, and the charge on the positive ion or positive radical is +1. So in this compound, the valencies are 1, 1. There will be exchange of valency when they come together, and I will get NH4 1, NO3 1. I'm keeping this in bracket because this radical or ion is not made up of one element. It is made up of nitrogen and hydrogen. Here too, the triazonitrate 5 anion is not made up of one element. It is made up of nitrogen and oxygen. So NO3 minus. So, but because they just appear once each, I can throw away the ones and the bracket. I'll get NH4 NO3. So that's the molecular formula of ammonium triazonitrate 5. Let's go to C. Zinc, let me write it here because of space. Zinc tetra oxo sulfate 6. Zinc tetraoxosulfate 6. Now, zinc is Zn2 plus. It's a positive cation. It's a positive ion or cation. Tetraoxosulfate 6 is an anion, SO4 2 minus. Everything should be kept together, no space. SO4 2 minus. So the charge is +2 on zinc. The charge of tetraoxosulfate 6 anion is -2. So from charges, I'll write their valencies. These numbers are called valencies. They are like the combining power of each of these ions. So there'll be exchange of valencies when the two ions come together to form a compound, and I will get Zn2SO4 2. You will notice here also that I did not write my Zn in bracket because zinc represents one element, but SO4 here is an ion comprising two elements, sulfur and oxygen. This ion is made up of one sulfur atom and 4 oxygen atoms. So I'm to keep it in bracket because everything is multiplied by 2. So in order to show that the 2 is multiplying the whole anion, I will keep this SO4 in bracket. But because there are, 2 appearing on both parts, I can remove the 2. In this particular compound, the 2's are removed, and I get ZnSO4. So my compound is ZnSO4. That's the molecular formula of zinc tetraoxosulfate 6. Let's go to D. D is copper 2 oxide. Copper 2 oxide. D is copper 2 oxide. So in this compound, the 2 here belongs to the copper, telling you that the copper is charged 2 plus. So Cu2 plus. Oxide is always 2 minus, except in peroxides. And this compound is not a peroxide. It's an oxide. It's a basic oxide. We'll get to that later. And it is charged 2 minus. So, and the oxygen in it is charged 2 minus. So copper is charged 2 plus. That gives you valencies at 2, 2. You will get, when you exchange valencies, Cu2O2. So the compound is CuO. If I remove these 2's by division, because they are similar, I will get Cu1O1. But because we don't write our 1, I can remove the 1's and get CuO. That's the molecular formula of copper 2 oxide. Let's go to the next question. Copper 1 oxide. Copper 1 oxide. In copper 1 oxide, the copper is charged +1. Oxygen is always -2 or 2 minus. So the valency is 2. The valency of copper here is 1. When I exchange valencies to form a compound with the 2 ions, I'll get Cu2O1. Because we don't always write our 1, I will throw the 1 away, and the formula of copper 1 oxide is Cu2O. In F is ion 2 tetraoxosulfate 6. Ion 2 means that the ion is charged 2 plus. Tetrasulfate 6 anion is always written as SO4 2 minus. So from their charges, I can write down their valencies. The valency of SO4 is 2. That of ion is 2. I will exchange valencies to form a compound with the 2 ions. That's Fe2SO4 2. You know the reason I'm doing this. Fe is a single element, or it's an ion of an element. SO4, it's an ion of 2 elements. It's made up of sulfur and oxygen atoms coming together in different ratios. So I have to put this in brackets when I'm multiplying it by 2. SO4 times 2. So because these 2's are similar, I can remove them. In some compounds they should be left, but most times we remove them. So I'll get FeSO4. I'm supposed to write Fe1. Actually, I was supposed to write Fe1 SO41, but because we don't write our 1, in algebra and in things like this in chemistry, I'll remove the 2 ones where they're supposed to be and leave it as FeSO4. That's the molecular formula of iron 2 tetrasulfate 6. Let's go to G. In G, the compound is sodium what? Sodium chloride. In G, the compound is sodium chloride. Sodium chloride here is made up of sodium ion Na plus and chloride ion Cl minus from charges which are what? +1 and -1 on each ion. I'll get their valencies 1 and 1. I'll exchange valencies. So my compound is Na1Cl1. So because we don't write our 1, the formula or the molecular formula of sodium chloride is NaCl. That's for G. H, the compound in H is iron 2. Let me write that R separately. Iron 2 sulfide. Iron 2 what? Sulfide. So in this compound, iron is charged 2+ because this 2 written here belongs to iron. Iron can exist. Iron is a multivalent element. It can be charged 2+, it can be charged 3+, so it can exhibit multiple valencies. So that's why when it's present in a compound, its valency is always stated. So because it's a transition element, we'll get to all that later. The sulfide here is S2-. Sulfide ion is always charged S2-. So from charges, I'll get their valencies, exchange the valencies, and I will get Fe2S2. In this compound, the common factors are removed, and the formula of the compound is written as FeS. No space between them. The F and the S should be closely written together. That's that for H. For I is ammonium what? Tetraoxosulfate 6. Ammonium tetraoxosulfate what? 6. So meaning that the compound is made up of 2 parts. The positive part is the ammonium ion, which is positively charged, and the tetraoxosulfate 6 anion, which is negatively charged. So from the charges, I'll write their valencies 1, 2. I'll exchange the valencies, and I'll get NH4 2 SO4 1. So the molecular formula of ammonium tetraoxosulfate 6 is NH4 2SO4. The reason I'm throwing away the bracket on SO4 is that it's multiplied by 1. And since I don't need to write this 1, then I don't need the bracket anymore too. I just write SO4 1. This is ammonium tetraoxosulfate 6. J is sodium hydrogen carbonate what? 4. Sodium hydrogen triacylcarbonate 4. Take note, this is the positive side of the compound. This is the positive side of the compound, and this is the negative side of the compound. Meaning this is the cation and this is the what? Anion. It's meant to be written together in a single file. My space won't let me, so take note. Sodium is Na+, it's charged +1. Hydrogen triacylcarbonate 4 is HCO3-. You'll see it on your list of cations and anions. So from their charges, I'll write their valencies. These numbers are their charges plus 1 minus 1. I'll write their valencies 1, 1. So here I'll exchange valencies, and the formula of the compound will be NaHCO3 1. I don't need to put Na in bracket. Na is sodium, representing just one element. But HCO3 is an anion which comprises 3 different elements. Hydrogen atom is there, carbon atom is there, oxygen atom is there too. So I need to put everything in bracket when I'm multiplying it by 1 here. But because I don't need to write my 1, so I can throw the 1 away. Once I throw the 1 away, once I throw this 1 away, the bracket will leave with it too. So the formula of sodium triacylcarbonate 4 is NaHCO3. That's that for J. Let's go to K. K is potassium. K is what? Potassium heptaoxodisulfate chromate 6. So in this, take note, this is the positive side, this is the negative side, this is the negative side of the compound. So this is the, that tells you the cation and anion. The cation is potassium ion. The heptazodichromate 6 is Cr2O7 2 minus. So from the charges, I write 1, write 2, minus 2. For minus 2, I write 2. This is the charge. This is the valency. This is the charge of the potassium ion. This is its valency. So to form compounds with the two ions, I'll exchange their valencies and get K2Cr2O7 1. But because I don't need to write 1, I can write K2Cr2O7. So that's the compound. Next one is L after K. Lead. L is lead trioxonitrate 5. Take note of the positive and negative part. Lead is Pb2 plus. Trioxonitrate 5 ion is NO3 minus. So this is the positive ion, this is the negative ion. So from their charges, I'll get their valencies 2, 1. Exchange their valencies to form a compound with the two ions, Pb1, Pb was 1, NO3 2. Because I don't need to write my 1, my compound will be Pb NO3 2. That's the formula of lead trioxonitrate 5. It's a salt. Then M is what? Tetra. M is tetraoxosulfate 6 acid. Take note, everything should be on a single line. So yours can be on a single line without breaking. I'm breaking it because after splitting my screen, the space is not going to let me write in one line. So tetraoxosulfate 6 acid. Anytime you hear acid, it means it contains hydrogen ion as the only positive ion. An acid is a compound which contains hydrogen ion as the only positive ion. When it dissociates in solution, we'll get to that later. So I can call this compound more completely. This compound is called hydrogen tetraoxosulfate 6 acid. I can put the acid if I like, or leave it if I don't. So hydrogen tetraoxosulfate 6. The hydrogen is charged H+. Tetraoxosulfate 6 ion. The tetraoxosulfate 6 ion is SO4 2 minus. So from their charges, I'll get their valencies 1, 2. Exchange the valencies, and my compound will be, the compound formed will be H2SO4 1. But because we don't always write our 1, tetraoxosulfate 6 acid is written as H2SO4. Take note of that too. N dioxonitrate 3 acid. Dioxonitrate 3 acid is also a compound that contains hydrogen ion as the only positive ion when it dissociates in solution or in water. So more fully or more completely, the name of the compound is hydrogen dioxonitrate 3 acid, if you like. But even if you don't put acid, it's already clear that it's an acid. So hydrogen dioxonitrate 3 contains hydrogen as the only positive ion, H+. The negative side is dioxonitrate 3 anion, NO2 minus. Excuse me. So from their charges, I'll write their valencies 1, 1. So to form compounds with the two ions, I'll exchange their valencies. That will give me H1, NO2, 1. So because we don't write our ones. I'll throw the ones away. I don't need to write this one again. I only need to write H, so I write my H. Also, I don't need to write this one here too anymore. I only need to write NO2, so I don't need the one. I also don't need to write the brackets anymore, so HNO2 is the formula of deoxynitrate 3 acid.